just a bit. Maybe trying, there we go. So if you remember at the end of class, I guess it would have been on Tuesday, you found a whole bunch of different ways using your pi plate to get 17 pi over 12. And we noticed a pattern that every single one of them has a pi over 4. So if you think of every pi over 4 as something over 12, you can choose any one of them as a starting point. Now let's say, like, sometimes people like to start with the one that's closest. Sometimes people just like pi over 4. Okay? If you started with the closest one, you would start with 15 pi over 12. So we would say this is equal to cos of 15 pi over 12. And then it's not hard to figure out what adds up to 17 pi over 12. Because you need a common denominator. Well, it would have to be over 12, and we need another 2 pi to add up. And when you do that and reduce it, well, we already know that 15 pi over 12 was 5 pi over 4. But when I reduce 2 pi over 12, I get pi over 6. And are both of those on your unit circle? Yes. And if you choose any pi over 4, now I wouldn't recommend choosing 101 pi over 4 in this situation, but it would still work. The mental math would just be a little bit more painful. But you could choose any pi over 4, and then once you've chosen that pi over 4, it's really, really easy to figure out what has to go with it to make it work. So let's see, which one did I do? I chose the 21. Probably because I know that I like adding better than subtracting, I probably pushed myself here to do a subtracting one just for fun. So 21's too much. What would you have to do? You'd have to subtract 4, and sure enough, when I reduce that, both of those are on your pi plate. And whether you used 7 pi over 4 minus pi over 3 as your alpha and beta, or 5 pi over 4 plus pi over 6 as your alpha and beta, you will get the same answer in the end, barring, of course, mistakes. Assuming you don't make any mistakes, you'll get the same answer. And so, just like double triangle questions, people really start to like pi over 12 questions because they're very predictable, and if you remember that you have to start with the pi over 4 family, then they become very easy to do. Because yesterday, as you guys were trying to find 17 pi over 12, some of you were trying all sorts of things and just couldn't find one. And now that I've given you the hint, you could use any pi over 4, you'd be able to find 5 or 10 or even more really quick. So notation-wise, okay, we wanted to find cos of 17 pi over 12. So when I write the equal sign, does it make sense I still have to write the cos? That didn't go away. But I just, instead of writing the 17 pi over 12, I broke it up to 21 pi over 12 minus 4 pi over 12. Then I wrote it again, but I reduced it so I could see the values on our pi plate. And here, I know alpha and I know beta. So when I go to my cos alpha minus beta formula, I can just plug in those things, and now this becomes a pi plate question. And what's nice about this unit is I said you could use your pi plate on your test. Even though you'll be able to use it on your test, I'm going to say try to do it in your head first. Try to keep it memorized so that you have it memorized, because you'll need it memorized for the final exam. I don't know if I told you this the other day. I had 2 former students that are taking high-level math in university did a presentation to the AP class. And they were asked, what are the 2 things that they used the most from high school in university math? And one of them was the unit circle. Knowing those unit circles, they said, keeps coming back over and over. The other was factoring. I got a little scared. I was afraid maybe they'd say, no, everything you learn in high school is useless. So what's going to happen then is I'm going to look at your values, and from your pie plate, I'm going to make sure that if you have something where, like 7 pi over 4 is in quadrant 4, sign has to be negative, so we have to make sure we have the right sign there. We make sure that we write out the formula correctly. The cos alpha minus beta formula has a plus sign in between. And then it's just a matter of simplifying. And as I mentioned yesterday, you will always have a root 2, a root 6, and a 4 for sine and cosine pi over 12 questions. And then sometimes on the exam, they have a follow-up question. Wow. And the follow-up question says, can you find secant of 17 pi over 12? Well, if you can find cos of 17 pi over 12, which we just did, does it make sense that secant would just be the flip of the answer? Okay, so in 7.5, or 7, yeah. I think I have some questions for you to circle. Or maybe I already gave them to you. Did I tell you to do question number 7? Have you circled number 7 already? And I have one more question from an exam that I'm going to show you, which is just a little bit of problem solving. Yeah, so circle number 7. We'll do this one as well. This showed up on an exam. What do you notice different in this question? It's a pi over 12 question, but what's different about it than the ones we've been doing? Yeah, there's a 4 out in front, right? Does that 4 make it any harder? No. You just do the cos of 11 pi over 12, and whatever answer you get, what are you going to do with that answer? Multiply it by 4. But again, it was interesting in marking this exam, how many students just left it blank because they're like, oh, there's a 4 in front. Don't get over, you see something a little bit different. Because the exam, I don't write your exam. Somebody else does. You're going to see a few things that are a little bit different. You would do it the same way. Okay? So, you pick a pi over 4. I'm going to take a peek. Oh, I picked pi over 4. So if I pick pi over 4, right, that's 3 pi over 12. Can you see that it's really easy to figure out what you would have to add to 3 pi over 12 to get 11 pi over 12? You would have to add 8 pi over 12. And actually in my work here, I temporarily ignored the 4. I'm going to deal with it in the end. Just going to look at the cos. 3 pi over 12 plus 8 pi over 12. That reduces nicely. That's my alpha, that's my beta. Plug it into your formula. And you can get your pi plate values. And then once you evaluate this, you get your root 2, your root 6, and your root 4, so then I wrote at the bottom, so if I put a 4 out in front, does that make sense that it would cancel? Basically, if you multiplied both sides of this by 4, those 4s would go away. And you would just get the root 2 minus the root 6. Okay? But on an exam, sometimes we get nervous, right? See something different, we have to just relax and say, there's going to be nothing on the exam that's not fair. Right? Like, could you multiply both sides of that equation by 4? Or is that beyond grade 12 math? No, it's fair. But sometimes when we see something new, we get nervous, and then I don't know if this ever happens to you, but your like brain just like turns to mush temporarily, because you get nervous. If you tell yourself, I can do this, you're gonna have nothing on the exam that is not fair, relax yourself, problem solve a little bit, and I'm sure you'll figure it out. But giving up is not usually a great strategy to use.